Ever wonder how, like, something as simple as a button press can make something complicated happen
Mm-hmm.
in, like, an electronic device?
Mm.
Or how your microwave, like,
Yeah.
somehow knows exactly when your popcorn's done?
Right. Yeah, those everyday miracles are thanks to these little tiny devices called microcontrollers.
Okay, so we're talking brains smaller than a fingernail.
That's right.
That's pretty incredible.
Yeah, and their journey started way back with microprocessors.
Okay.
Now, those were revolutionary, but they were pretty complex
Yeah.
and power hungry, and so what the world needed was a more compact and
Right.
efficient solution for dedicated tasks.
So it was like the difference between having like a whole orchestra for like
Yeah.
just like one solo
Yes,
versus like one guy who could play all the parts.
that is a perfect analogy.
Okay.
And that's where microcontrollers come in.
Okay.
One of the key milestones was when the Intel 8051 came around in 1981.
The 8051,
Yeah,
that sounds like a legend in the microcontroller
it
world.
really is.
Oh,
Yeah, the 8051 was one of the first to really embrace this idea of a self-contained system
okay.
designed specifically for embedded applications.
Embedded applications.
Yeah.
So not just like your desktop PC, but like
Right.
more specific tasks within
Yeah, exactly.
ICs.
Think about it. Your microwave doesn't need to run, some fancy software or connect to the internet. It just
Mhm.
needs to,
Do its one job.
manage a few very
Yeah.
specific
Yeah.
functions. And the 8051 was just perfect for that.
Okay, so the 8051 was the perfect person for the job, and
It
then
was. And here's what's really interesting is that Intel made their architecture available to other manufacturers.
okay.
So you had all of these variations and
So
applications.
it wasn't just Intel making 8051s,
Right.
but everyone was like,
It
"Oh,
was like a blossoming.
we can tailor this and make our own."
Exactly. And this open approach
Yeah.
really fueled innovation in the microcontroller world.
So we have this pivotal moment with the 8051,
Yeah,
but it doesn't end there, obviously.
of course not.
The story keeps going.
Alongside the 8051, you had other 8-bit microcontrollers,
okay.
each with their own strengths and features.
Okay.
There was the Z8 from Zlog,
Okay.
known for its efficiency, and then there was the PIC series from Microchip,
Okay.
which gained popularity because it was so affordable
Yeah.
and easy to use.
So it was like friendly competition between all these
Yeah,
companies.
exactly. As technology advanced, the demand for more processing power grew.
Yeah, of course.
So then we had, 16-bit and even 32-bit microcontrollers.
Wow.
So it was like these tiny little brains just kept getting smarter and more capable.
It's amazing to think that something so small can be so powerful.
Yeah.
But before we get too far, I think it's important for us to like understand how
Yeah,
microcontrollers differ from those early microprocessors.
absolutely. That's a very common point of confusion.
Yep.
Think of it this way. A microprocessor is like the conductor of an orchestra.
Okay.
The central processing unit manages the flow of instructions.
Yeah.
The data. Uh-huh.
But it needs other components like memory,
Right.
input-output devices, storage to make the whole computer system.
So the microprocessor is the brain, but it needs the whole body.
Exactly.
Function.
Right.
Now, a microcontroller is more like a solo musician who can play multiple instruments at once.
Okay.
It integrates the CPU, the memory, and input-output
Yeah.
peripherals
Uh-huh.
all on that single chip.
So it's a streamlined all-in-one solution for whatever task.
Precisely. And this fundamental difference in design and purpose has led to microcontrollers becoming just ubiquitous
Yeah.
in our modern world.
Okay, so now that we've set the stage, I'm curious to like peek inside these
Right.
tiny marvels.
Yeah.
What makes them pick?
Well, despite their size, they're packed with these essential components.
Okay.
At their core is the CPU, the brain,
Uh-huh.
that fetches and executes instructions.
So it's the command center making sure everything
Beep.
runs smoothly.
Then you have the memory,
Okay.
which includes ROM, to store program instructions, RAM for temporary data during execution,
Okay.
and sometimes EEPROM, which allows for data to be stored even when the power is off.
So it's like you have a library for the program, a workspace,
Eh,
and then like
yeah.
a safe deposit box
That's a great way to put it.
for important information.
And then there's timers and counters,
Okay.
essential for precise timekeeping and event counting.
So it's like the ticking clock that makes sure everything happens at the right time.
Exactly. And crucially,
Yeah.
we have the I/O ports. These are the gateways
Okay.
for the microcontroller to interact with the outside world,
Okay.
taking input from sensors controlling actuators.
So like its senses and limbs allowing it to
Exactly.
perceive the world around it?
Precisely, all these components work together in perfect harmony,
Wow.
enabling the microcontroller to perform a wide range of tasks.
It's like we're uncovering this whole microscopic universe inside
It is.
these tiny
And
chips.
this microscopic universe has led to some truly remarkable applications. But that's a story for another time.
Okay, I am eager to hear about these remarkable applications.
Right.
It's mind-boggling to think about all the places these tiny little
Absolutely right.
microcontrollers might be hiding.
They're practically everywhere, from the mundane to the extraordinary.
Give me some examples. I need to know where to start looking for these
Yeah.
hidden heroes.
Well, let's start with something close to home.
Okay.
Think about your kitchen appliances, your microwave, your oven refrigerator,
Yep.
dishwasher, even your coffee maker. They all rely on microcontrollers.
So when I set the timer on my oven,
Yes.
it's a microcontroller that's keeping track of the time and
Okay,
divide,
that's great.
controlling the heating element.
Precisely. And when you select a wash cycle on your dishwasher,
Yeah.
a microcontroller is orchestrating the water flow, the detergent dispensing, and the drying cycle.
Wow. I never realized how much we rely on these tiny devices without even knowing it.
It's true. And it's not just our kitchens. Step into your car and you'll find microcontrollers managing the engine control,
Wow.
anti-lock braking system, airbag deployment, even the entertainment system.
So they're not just like making our lives more convenient,
Right.
but they're also playing like a crucial role
Absolutely.
in our safety on the road.
And their impact extends far beyond our homes and vehicles. Microcontrollers are essential in industrial automation,
Okay.
controlling complex machinery in factories and manufacturing plants.
So it's like they're bringing that precision and intelligence of computers
Exact.
to the world of heavy industry.
They're enabling increased efficiency, reduced waste, and improved safety in countless industrial processes.
Wow.
And we can't forget about the role of microcontrollers in healthcare.
Oh, right. I've heard about medical devices being powered by microcontrollers.
It's true, they're at the heart of pacemakers, insulin pumps, hearing aids,
Wow.
and countless other devices that are improving the quality of life for millions of people.
Okay, I'm starting to see a pattern here. It's like microcontrollers are
Yeah.
touching nearly every aspect of our modern world.
They really are, and their impact is only going to grow as technology continues to advance. One
Yeah.
of the most exciting areas of growth is the Internet of Things.
The IoT, I've heard that term thrown around a lot,
Yeah.
but I'm not entirely sure what it means.
It's essentially the idea of connecting everyday objects to the Internet, allowing them to collect and exchange data.
Okay.
And guess what's at the heart of many of these connected devices?
Microcontrollers.
They're the brains behind smart home devices, wearable fitness trackers, environmental sensors,
Wow.
and even autonomous vehicles.
This is incredible. It's like we're on the verge of a world where everything around us
Yeah.
is intelligent and interconnected.
And microcontrollers are playing a pivotal role in making that vision a reality.
Okay, I am officially blown away by the sheer scope of their applications.
Right.
But with all this incredible power packed into such a tiny space, are there any limitations?
That's a great question. And the answer is, of course, there are limitations. One of the key challenges in microcontroller design is managing power consumption.
Right, because we're talking about devices that are
Exactly.
often running on batteries
Yeah.
or in environments where power is limited.
So engineers are constantly working on ways to make microcontrollers more energy efficient,
Okay.
optimizing your circuits and developing power-saving modes.
So it's like trying to squeeze every last drop of performance out of a tiny battery.
That's a good way to put it. Another challenge is dealing with the inherent limitations of digital systems when interfacing with the analog world.
Right, because the real world is full of like
Exactly.
continuous signals, like temperature, light, sound,
Right.
while microcontrollers think in ones and zeros.
Exactly. And that's where analog to digital converters, or ADCs, come in.
Okay.
They act as bridges between the analog and digital worlds,
Okay.
converting those continuous signals into discrete values that the microcontroller can understand.
So it's like having a translator that helps the microcontroller interpret the language of the real world.
That's a great analogy. But even with ADCs, there are limits to how accurately and quickly microcontrollers can sample and process analog signals.
So there's always a trade-off between speed accuracy and
Exactly.
power consumption.
And finding the right balance is one of the key challenges in microcontroller design.
Okay.
Another limitation is the processing power itself.
Right, because no matter how advanced they become,
Right.
they're still constrained by that size and complexity of the chip.
Precisely. While microcontrollers are getting more powerful all the time, they're still not suitable for tasks that require massive computational power,
Okay.
like complex simulations or high-resolution video processing.
So they're not about to replace our desktop computers anytime soon.
Not for those kinds of tasks, no, but within their domain of embedded applications.
Yeah.
They're already pushing the boundaries of what's possible.
This has been incredibly insightful. It's fascinating to see how these tiny devices are both incredibly powerful
Right.
and yet subject to certain limitations. It's like this delicate dance between capability and constraint.
That's a great way to put it. And understanding those limitations is just as important as appreciating their capabilities.
Yeah.
It allows us to design and deploy microcontrollers effectively and responsibly.
Speaking of design and deployment, I'm curious to know more about the actual process of working with these microcontrollers.
Yeah.
It sounds like a fascinating blend of hardware and software.
You're absolutely right. And that's a topic that deserves its own exploration.
Okay.
But for now, I think we've covered a lot of ground,
Yeah.
from the historical development and inner workings of microcontrollers to their vast range of applications
Yeah.
and the challenges they face.
Okay, so let's delve into that fascinating blend of hardware and software you mentioned.
Right.
It sounds like working with microcontrollers requires like a very special
Yeah.
set of skills.
You're absolutely right. It's a multidisciplinary field that combines elements of electrical engineering, computer science, and even a bit of artistry.
Artistry. That's an interesting way to describe it.
Well, think about it. When you're designing a microcontroller-based system,
Yeah.
you're not just writing code, you're creating a symphony of interactions.
All right.
Between the microcontroller and the physical world. You need to understand how the hardware works, how to write efficient code,
Right.
and how to orchestrate those interactions to achieve the outcome you're looking for.
I like that analogy. It's like you're composing a piece of music,
Exactly.
but instead of notes, you're using bits and bytes.
So let's break down the process first.
Yeah.
You got to choose the right microcontroller for the job, which we kind of already talked about.
Yeah.
Then comes the hardware design. This involves connecting the microcontroller to various sensors, actuators,
Right.
and other components, creating that physical framework for your system.
So it's like building the stage for the microcontroller to perform on.
Exactly. And this stage needs to be carefully designed to make sure everything's connected right
Yeah.
and that the signals are flowing smoothly.
I imagine that could be quite challenging.
It can be, but thankfully there are tools and techniques that make the process much easier.
Okay.
For example, you have breadboards,
Yeah.
which allow you to prototype circuits quickly and easily without soldering.
Okay.
And then there's software tools that help you design and simulate circuits before you even touch a physical component.
So it's like a virtual sandbox where you can experiment and refine your design.
Exactly. And once that hardware is in place,
Yeah.
then it's time to write the software.
Okay.
This is where you bring that microcontroller to life using programming languages like C or assembly language
Sure.
to write the instructions that'll control its behavior.
So it's like giving the microcontroller its script,
That's a good way to think about it.
telling it exactly what to do and when to do it.
And this script needs to be carefully crafted to make sure that the microcontroller is interacting with the hardware correctly
Right.
and that the overall system is functioning as you intended it to.
I can imagine that debugging can be quite tricky, especially when you're dealing with a device
It can,
that's essentially a black box.
but thankfully there are specialized tools called debuggers
Yeah.
that allow you to step through your code line by line, examine the contents of memory,
Okay.
and monitor those signals going in and out of the microcontroller.
So it's like having a window into the microcontroller's mind.
Precisely.
So you can see what it's thinking and how it's reacting to the world around it.
And with these tools, you can pinpoint errors in your code or hardware design
Right.
and make adjustments until everything's working perfectly.
So this is all starting to sound very intricate and technical.
Yeah.
Is this something that like anyone can learn, or is this just for like seasoned engineers?
That's a great question. And the answer is it's accessible to anyone with a passion for learning and a willingness to tinker.
Okay.
Of course, having a background in electronics or computer science can help.
Right.
But there are countless resources available for beginners,
Okay.
including online tutorials, books, and even kits that provide everything you need to get started.
That's encouraging to hear. It's like
Yeah.
any new skill, you know?
Yeah,
It just takes time and dedication.
exactly.
But once you have those skills, What kind of possibilities open up?
The possibilities are truly limitless.
Wow.
With a little creativity and ingenuity, you can use microcontrollers to create anything you can imagine.
Really?
You could build your own smart home devices, automate tasks around your house,
Wow.
design custom gadgets, or even create your own robots.
That's inspiring. It's like having a superpower in your pocket.
Yeah,
The ability to bring your ideas to life using these tiny
exactly.
but mighty devices.
And as the world becomes increasingly reliant on technology, the demand for these skilled microcontroller developers is only going to continue to grow.
Yeah.
So it's not just a fun and rewarding hobby, it's a valuable and in-demand skill set.
This has been an eye-opening journey into the world of microcontrollers.
It has.
It's amazing to think that something so small
Yeah.
can have such a profound impact on our lives.
It really is. And as we move forward, it's exciting to think about all the new and innovative ways that microcontrollers are going to shape our world.
Well, thank you for sharing your expertise and your passion with us today. I feel like I've gained
My pleasure.
a whole new appreciation for these tiny titans
Yeah.
of technology.
It's been my pleasure. And to our listeners, I encourage you to explore the world of microcontrollers and discover the incredible power that lies within your grasp.